In this example, we're using a standard deck of cards. The game you're playing requires you to draw 7 cards, and you're going to win the game if you get at least 5 hearts. In order to better visualize the examples, I'm going to draw 7 cards. First, we need to define what is a success and what is a failure. Because winning the game is getting a hearts, a failure would be getting a card of any other suit. It does not matter how many you're going to be required to get, just that if somebody flips over a card, you're excited and happy if you get one that is a heart, and you're not happy if you get a card that is any other suit, like a diamond, a club, and so on. Now, the values that need to be set are the number in the trial and the probability of success. Your N is going to be the 7 cards that you are drawing. Your lowercase p, or the probability of success, is 13 out of 52 because you have 13 out of 52 cards. You have to think about the classical probability working with a standard deck of cards of how many hearts there are out of the entire deck. Now, if you are able to simplify that fraction to a terminating decimal, then you will be allowed to use that decimal. Otherwise, you will have to use that exact fraction in all of your setups. 13 out of 52 is in fact 1/4, so I can write that as 0.25. As you move through finding the probabilities, the x value is the one that is going to change. In this first part, we're asked to find the probability of getting at most 3 hearts. At most is our trigger word that lets us know that we need to use binom CDF. Remember that CDF is going to give us up to and including the number that we want. So here I'm going to use up to and including 3. When writing the probability of the event, you're going to set this equal to the calculator feature. Remember that this is because your calculator feature is really a setup of a fraction with a lot of other operations that are happening in the background. So it's important that you follow the procedure exactly the way that I'm showing you. Binom CDF is in the distribution, so you're going to need to hit second and vars. Using your up or down arrows, you need to find B. Then hit enter. You can now enter the number of trials, the probability of success, and the x value. Once you hit enter, you'll notice that on your calculator it looks exactly like what is on your paper. And now you can round to 4 decimals. So the probability that you will get at most 3 hearts when you see 7 cards being drawn in front of you is 0.9294. Let's look at finding the probability of getting exactly 4 hearts. The word exactly triggers binom PDF. And again, our number of trials is fixed, along with our probability of success, so our x value is the only thing that changes. The process for getting there is still the same, but now you're looking at letter A. Entering in the values and hitting enter. Again, you will see this on your calculator screen. And when you round to 4 decimals, you get 0.0577. The trickier type is find the probability of getting at least 5 hearts. At least 5 means I want the upper section of our values. So I have to think about how complements work along with my binom CDF. If I look at all of my probabilities, they must sum up to be equal to 1. The probability of at least 5 is the probability of 5, 6, and 7 totaled up, which means everything up to and including 4 is what I don't want. And I can use binom CDF to do this. If I just subtract this from 1, I will get what I'm looking for. So the probability of at least 5 hearts is equal to 1 minus the binom CDF. When you enter this into your calculator, make it look exactly like what's on your paper. Start with 1 minus before you go and find the binom CDF. This way, when you hit enter, you know you'll have the exact value you're looking for. And now I can round my final answer. Again, be sure that when you are setting up your probability of the events, that once you hit your equal sign, you set up the calculator feature before you hit your